Sorry I can't be here today, you guys, but I figured I'd throw together a video so that you didn't have to learn this stuff on your own. Today's topic is synthetic division, and you can follow along with your notes with me today. So, synthetic division can be used to divide a polynomial by an expression of the form x minus k. When the degree of the denominator is 1, synthetic division can be used. However, dividing by something like 2x minus 1 requires a transformation of the polynomial. So we're going to mainly look for stuff that is in the form of x minus k that we're going to divide by. However, 2x minus 1 can be used. So example 1 asks, when can you use synthetic division? And just very simple, we're not going to do anything. We're just saying, when can you use it? So circle the following problems that can be used using synthetic division. If not circled, explain why not. So very first one right here, we have x squared plus 3x minus 6 being divided by x plus 1. So if we're dividing by x minus k, we can divide. This one is good to go because it's in an x plus 1 form, so we can use that one. Your second one over here, x cubed and then divided by an x squared, we are not going to be able to do this one, so I'm not going to circle it because the degree is 2. We only divide if the degree is 1. So the degree of the denominator is 1 is what I'm looking at there. Okay. This one right here, you look at it and you kind of wonder, this isn't quite an x minus k, but it does fit the however example at the top where it says you can divide by 2x minus 1. So this is possible, but it's going to be more difficult. And we will not go over how to do that here today. The last one here, you look at it, make a decision right now. Answer you should answer is no, because it's not a degree of 1. And I'm going to go ahead and put a question mark next to those. That's why we cannot do those. So we can't divide if it's a degree of 2 in that case. Okay, so we're going to go on to our first example in the pattern and how this all works. So when you do synthetic division, you're going to get rid of all of the x's, which is what makes it synthetic. It works to divide this way, but it's just kind of an interesting thing. The way synthetic division will be set up is you're going to set up an L chart, and some people will set this up differently. I think this is the easiest way to organize it. So you set up an L. Your number you're dividing by is going to go out here, and it's not going to be this. It's going to be the 0 or the root or the solution if you were solving with x minus 1. So it's going to be 1 in this case, not negative 1. And then your coefficients of each term are going to go across here. So if we look at this, 5x to the fourth minus 2x third minus 3x to the second plus 5x plus 1, it doesn't skip any terms through here. When we get to some of those later on, you'll see how that works. But notice there's an x to the fourth, an x to the third, an x to the second, an x to the first, and this is technically an x to the 0. So none of them are skipped. They're also all in the right order, so you can just write them in that order. So the first coefficient is a 5, the next coefficient is a negative 2, the next coefficient is a negative 3, the next one is a 5, and the last one is a 1. Notice I gave myself space in here because you want to be able to do this synthetic division. Okay, so the pattern that occurs to do synthetic division is you bring down the 5, so you put the 5 down here. You multiply this 5 by this 1, so you multiply times 1, and you put that number up here. So the 5 times 1 is 5. You then again add through here. Negative 2 plus 5 is 3. And you multiply that by that 1 that was out here. 3 times 1 is 3. And that number goes up here. Again, you add down here. Negative 3 plus 3 is 0. 0 times that number that was out front. 1. 0 times 1 is 0. That goes over here. You add going down. 5 plus 0 is 5. You multiply that by the number that was out front, so times 1. 5 times 1 is 5. And again, you add going down. 5 plus 1 is 6. Once you have this last number under your last number here, you're done. So you're not multiplying by 1 again. Now you have to understand how you are reading this. And the way that you're reading this is that you're dividing. So you're taking an x to the fourth and dividing by an x term. That means that we're going to get down to an x cubed term because x to the fourth divided by x is x cubed. But the way to go through this is essentially to work backwards. So the very last number here, since we're going down one term, is no longer the x to the 0. This is actually called our remainder. So when you divide, if you divide something like 7 divided by 2, you get that it's 3 with a remainder of 1 left over. So we still have a remainder here, a remainder is 6. This first number then is my x to the 0 term. which we don't, this is just nothing, so that's just going to be a constant. This is your x to the first term, this is your x to the second term, and this is your x to the third term. So notice how I worked my way up from the remainder, and my exponent is going up from here. So to write your answer to this question, your answer would be a 5x to the third, so that's my coefficient of this one, plus, in this case, because it's positive, a 3x to the second, and then this is a 0x to the first. So first of all, x to the first is just x. 0x is nothing, so I'm going to skip over this term and go over here, and this is a 5x to the 0 term. Now x to the 0 is my constant term. This goes away, so I'm just going to write it as 5. So it's plus 5, and this answer has a remainder of 6. So this is my answer and the general idea of what we're going to be doing through synthetic division here. Finish out the beginning of this, our example 3, understanding the parts. So we're going to write the polynomial form of the dividend, divisor, quotient, and remainder represented by the synthetic division array. So understanding these different words is a big deal. When you are doing division and you're doing long division, you tend to write your division like this. Your dividend is this number under here. Your divisor is the number that you wrote you're dividing by. Your quotient is what you get. And your remainder is what you write off to the side usually. So just to give you an idea of where all of those words come from. So in synthetic division, we're looking at this to try to figure those out. So our dividend was the number that was under here that we're dividing out. So this is what we're dividing out. Now we have to work our way back through it. So this is our x to the 0 term. This is our x to the first term, or x. This is our x to the second term, and this is our x to the third term. So that's the number that I'm going to get there for my dividend. So it's 1x to the third, which is just x to the third, minus 2x squared, minus 14x, minus 5. That's my dividend. You go through then, your divisors, what are you dividing by? So I'm dividing by this 5 over here, but we have to remember what the 5 represents. It represents an x minus 5. So that means that my divisor is x minus 5 in here. And then my quotient is my answer. So my answer comes down here. So a reminder from what we just did, this is our remainder. This is our x to the 0 term. This is our x to the first term. This is our x to the second. Notice we took an x to the third and we divided by an x. We're going to get an x to the second. Okay, so our quotient here, if I write it out, is x squared plus 3x. Again, I could do this first, but 3x is the same thing. And plus 1, x to the 0 is just your constant term. Your remainder in this case comes out to be 0, so your remainder is just 0. Go ahead and take a second and do this one right here. We can go ahead and pause the video, and then when you guys are done, you can play it to make sure that you got it right. Okay, we're back now. So my dividend should come out to be x to the third plus x minus 2. My divisor should come out to be x minus 3. My quotient should be x squared plus 3x plus 10, and my remainder is 28. So check and hopefully you got all of those right.